All right, folks, today we're going to look at the transformations of the sine function. So a lot of these we've already seen. Actually, all of these we've already seen. We just haven't applied it to the sine curve yet. So we've got our A value, we've got our D value, we've got our C value. So before we get into all of those little bits and pieces, let's recap some of the things about the sine function. So remember, a sine function is sine x. We're measuring it in degrees. It's periodic, which means it repeats. Its sinusoidal function just means that we've transformed it. Those words are frequently used interchangeably. Period is the length of one cycle, so sine is usually characterized by that cycle. Okay, we have maximum values up top. Our minimum value is down below. The axis is the line that's in the middle. And to get that formula, remember we take our maximum and we add it to the minimum and divide it by 2. To get our amplitude, it's almost the same thing. We take our maximum and we minus it from the minimum, divided by 2. So our amplitude is here, amplitude is here. Right, it's half the height. In the sine curve, here's a nice lovely sine curve. So the period of the sine curve is defined as 360 degrees. So from start to end for one cycle is 360 degrees. The maximum value is 1. The minimum value is -1, so that's down here. The equation of the axis is down the middle. So the equation of the axis, so that's down the middle. So on just plain old sine, that's at y equals 0. My amplitude, well, it goes up to 1. So I can draw that to the peak or to the trough. So my amplitude is 1. My domain, there's no restriction, so x is any real number. The range, well, y is any real number, but y has to go between the minimum, less than or equal to 1, y less than or equal to +1. So it has to go from the minimum underneath to the maximum, which is up top. Okay, so then in our picture, we've got 5 main key points that we have to worry about. We're going to worry about 0, 0. We're going to worry about 91, so that's my maximum. We're going to come back to 0, 0. We're going to deal with our minimum, which is at 270, -1. And we're going to come back to 0 at 360 degrees. So we've got our maximum, we've got our minimum, and then we've got our 3 zeros in the middle. Oops, that should say 180. Not 0, 0, 180. Okay? Okay. So here I've got a function. It's been transformed slightly. And let's not forget that our basic function looks like a sine x minus d plus c. So here I've got a number out to the outside. And remember, plus c, well, that's our vertical transformations. So our c value in this case is -3, which means I have a vertical translation, and minus means I'm going down that many. So that means my y values are going to all get subtracted by 3. I'm not doing any changes to my x values in this one. I'm only changing my y values and bringing them down 3. So I'm going to have 0 minus 3, which is -3. I have 1 minus 3, which gives me -2. 0 minus 3 gives me -3. -1 minus 3 gives me -4. And 0 minus 3 gives me -3. So my new dots are all going to be at the same x values. They just have a new y value. So I'm going to be at 0, -3, 90, -2, 180, -3, 270, -4, and 360, -3. So I'm now at -3, -2, -3, -4, -3. Nice curvy, oops, curvy, do the best you can. It is not easy. My domain and my range. So my domain is always, always, always x is any real number. my range is y is any real number. I have to go for my minimum, which is -4, less than or equal to y, less than or equal to my maximum, which is -2. My equation of my curve of my axis, so my middle line, goes right through all these repeating points here. So my axis is going to be at y equals -3. That's my c value. Right? Because I've slid the whole thing down. So my axis has to slide down 3 as well. Okay, let's do the next one. So here I've got sine x minus 60. So I've now got the number inside the brackets. So we know our general formula looks like this. So inside the brackets, well, that's what I've got. So that means I have a d equals 60 degrees. And that means it's now a horizontal translation. And minus means I'm going to the right 60 degrees. So that means my x values, I'm going to be plussing 60 degrees. So that means I'm going to have 0 plus 60, which gives me 60, 90 plus 60, which gives me 150, 180 plus 60, which gives me 240, 270 plus 60 gives me 330, and last but not least, 360 plus 60 gives me 420. My y values, nope, there's no change, so I don't have to worry about that, which means my point is 60, 0, 151, 240, 0, 330, -1, and oops, 420, 0. Okay, let's pop them on our curve here. So I've got a 60, 0, 151, 240, 0, 330, -1, and 420. Oh, it's over here somewhere. Right there. So let's do a nice curve. 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 And what am I doing up there? 0. Very nice. That actually wasn't too bad. So my domain, x is any real number. My range, y is any real number such that minimum, I didn't change, so it's -1, less than or equal to y, less than or equal to our maximum, which is 1. Right? Remember, there's my min. There's my max. Here's my max. Here's my min. Right? Haven't changed those. Those are my points up here. There's my max. There's my min. And my axis of symmetry, which goes down through the center, well, that's all of these 0 points. That's got my axis. That's on my axis. That's on my axis. So since I didn't go up and down at all, it's still just at y equals 0. Okay, next. Ooh, now I've got 2 things going on in there. So let's not forget y equals a sine x minus d plus c. So I have a 45 in the middle, right, inside the brackets. So that means I have a d value of -45. So that means I have a horizontal translation. And because it's minus, I'm going to the left 45 degrees. And this number outside the brackets, that's my c value. So that means I'm doing a vertical translation. And because it's positive, I'm going to go up 2. So when I go to put this into my points, let's see. X's, I have to go left 45. So I'm going to take my x value, 0 minus 45, which gives me -45. Okay, let's try that again. 90 minus 45 gives me a positive 45. 180 minus 45 gives me 135. 270 minus 45 gives me 225, right? 3070, yeah. And 360 minus 45 gives me 315. Okay. Y values, since we've got this plus 2, I'm going to have to take my y plus 2. So I've got a 0 plus 2 gives me 2. 1 plus 2 gives me 3. 0 plus 2 gives me 2. Negative 1 plus 2 gives me 1. And 0 plus 2 gives me 2. So my new point, the one I'm going to graph, is going to look at negative 45, 2, 45, 3, 135, 2, 225, 1, and 315, 2. So let's graph it. Let's see, did I give myself enough space here? Probably not. All right, so let's see. We've got negative 45, 2, 45, 3, 135, 2, 225, 1, and 315, 2. Make it curvy, 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 curvy. So there is y equals sine bracket x minus plus 45 plus 2, right? Because it came to the left. So my domain, no changes. X is any real number. Range, y is any real number, such that, let's see, our minimum is at 1, less than or equal to y, less than or equal to 3. And the equation of our axis has now shifted to up here. So it's going through the middle, goes through where all those 0 points all are, and that's going through at y equals 2. There's my axis. Straight on through the middle. Nice. Okay, let's do another one. More the merrier. Now let's stick a number in front. So when we stick that number in front, that a value, remember if it's bigger than 1, we are stretched. If it's between 0 and 1, it's compressed. And if it's negative, we are reflected in the x-axis, okay? So let's work on that one. So here I have y equals 2 sine x. So my a value is 2, which means I am vertical stretch by factor of, that just means multiply it, vertical stretch by factor of 2. So when I go to put it into my points, my y values now will have to be multiplied by 2. I don't have a phase shift in this one. I don't have a vertical shift in this one. I just have a y times 2. So my 0 times 2 is going to be, well, 0. 1 times 2 is 2. 0 times 2 is 0. Oh, I like that 0. Negative 1 times 2 is negative 2. And 0 times 2 is 0. So my x values are not changing. Just my non-zero y values. So we've got 180, 0. 270 is now negative 2, and 360 is still at 0. So my zeros stay at zeros. My 1 becomes a 2, and my negative 1 becomes a negative 2. So I've stretched it vertically. So I now look like that. So my domain has not changed. It will never change. My range, y is any real number, such that my new minimum is negative 2, less than or equal to y, and my new maximum is positive 2. I'm still going around the line y equals 0 as my axis. Right, so that's still there because it's going through the center. And there we have it. Good! Almost done, folks. Ooh, let's do one that's got more than one thing in it. So here I have an a value of negative 3. So, ooh, negative. I now have a reflection in my x-axis. And I have a vertical stretch by factor of 3. So both of these things I can take care of down here, because I'm going to take my y value and I'm going to times them by negative 3. I do have this plus 4 on the outside here, so that's my c value. So c value is 4, which means I now have a vertical translation, and we're going to go up 4. So I'm not doing anything to my x's, but after I've multiplied it, order of operations, I'm going to take my y and I'm then going to plus it by 4. Okay, and that's my new y. New y is going to get plus by 4. So you have to multiply first, and then you can add. So let's see. 0 times negative 3 gives me 0. 1 times negative 3 gives me negative 3. 0 times negative 3 is 0. Negative 1 times negative 3 gives me a positive 3. 0 times negative 3 gives me 0. So I'm going to take those numbers, and I'm going to do this plus 4. So 0 plus 4 equals 4. Negative 3 plus 4 gives me 1. 0 plus 4 gives me 4. 3 plus 4 gives me 7. And 0 plus 4 gives me 4. So my new points are going to be at, let's see, x's didn't change, just my y's. So 0, 4, 91, 184, 277, and 364. So let's see, 0, 4, 91, 184, 277, 364. Curvy up. Oops, I missed a little bit. Curvy down. And there you have it. Y equals negative 3 sine x plus 4. Domain, x is any real number. Range, y is any real number such that, let's see, our minimum is at 1. Less than or equal to y, less than or equal to maximum, which was 7. And our equation of the axis, so we had a c value, so y is now equal to, what was my c value? 4. And if we look, well, that's where all of those little 0 points all are. They're all going through y equals 4. Right? That's that number. That's that number. That's that number. Nice. Oh, we're so close to done. Oh, let's write an equation. So now I'm going to give you the words. You put it into the equation. So let's not forget y equals a sine x minus d plus c. That's what we're working with here. So what do we got? I have a horizontal translation of 20 degrees to the right. So that means I need a minus 20 in there. I have a vertical translation of 3 up. So I'm going to go plus 3 there. And since that's all I'm being told, finish off with a y equals sign in front. Good. All right. Next one. Horizontal translation of 35 degrees to the left. So that means I'm going to have an x plus 35. I have a vertical translation of 5 units down. So that'll be minus 5 on the outside. And I'm sure we can add in here a vertical stretch. Let's add in a vertical stretch by a factor of 10. So a is going to be 10. So that comes out front. Finish it off. Oops, that's in the wrong spot. Finish it off with a good old y equals 10 sine. And away we go.